All right, so let's see how this would work out in code actually. So let's go ahead and actually try to code this. We're going to use the same test firm helper function that we have used for the permutations with repetitions. So, but this time let's give ourselves another function that returns the same result in a vector of integers string, and let's call it just perm, okay, with no repetitions. So perm, and it would take the same input, which is string k, string, and the subset size k, and uh, it's going to give us the same partial for building up our partials and the vector of strings to store the result. So, and then let's call from helper, and here we're going to pass in the uh, the input s, k, and partial. And remember, one thing we have to pass here is the current offset. So we have to pass in the current offset, and then pass in the result, right? So, all right. So let's write our recursive function. Well, uh, we have to return the result. So return the result. Okay. So let's look at our helper function, which will be actually helping us calculate all the uh, subsets. So string s as usual, and int k, which is the subset size, uh, and then we need to pass in the partial string that we have built up so far, and let's pass in the offset, and then we need the vector string to store the result as usual. All right, so like previously, we are going to end our recursion or the branch at when the partial, right, size, partial size is equal to the subset size, then we want to collect that, collect that, and we want to store that in result push back, and uh, add partial to that, and then return. So we would have collected the required unique subset. And so the for loop is going to look like a, let's call our I, and I would now begin from the offset. So I would begin from the offset, and I will go to the size of the string, which is s dot size, and then plus I. Okay, so that is what our for loop was. And now we need to call this form helper. But before that, remember we were swapping the offset. So the current offset with the current iteration variable. So when we are beginning, so we start with 0, 0 swap with 0, or 0th offset swap with 0 is not going to change anything. Remember that we are assigning I equals to offset for every new iteration. So the first swap of s of, let's say, offset with s of I is not going to make any difference. But this would give us a unique permutation in the next iteration when I will increment. So let's call that swap, and then let's call our perm helper. Let's call our perm helper with s, and the size, subset size, and then partial plus offset, partial plus s of offset. So we get the character, the current offset, and then we pass in the offset has to be incremented by 1, and then we pass in the result, right? So that we can store that. And then once we are done obtaining that, let's restore the string back to its normal. So that would be offset swap it with s of I. Right? So we restore it back. Okay, so that completes our recursive loops, and we every time we get the new offset, we swap it, and then when I increments, then we're going to swap it again. So let's go ahead and save this, and instead of calling perm rep, uh, let's call the perm and see uh, what it gives us. So I'm going to go ahead and run this. Let's go ahead and run this. So uh, okay, couple of errors. 947. This was not declared in this scope. Uh, oh, okay, sorry. I was too busy thinking uh, about inputs. So this is and got totally forgot about their types. That and 48. Okay, so all right. So that should probably take care of most of the errors. Okay, so we have a couple of warnings in the for loops. So maybe we can, instead of using an integer, we can use a size underscore t. But for now, let's just go ahead and run this my target. Okay. Didn't return anything, maybe because I was not passing the see, that's the mistake. So if I'm not passing it by reference, then nothing gets stored in. Okay, so let's go ahead and pass it by reference, and then save it so that we can see the results. Okay, I'm going to execute that, and we get ABC, ACB, BAC, BCA, CBA, and CAB. So that matches our expectation. So if you look at uh, the branch here. So we collect what is there at the first offset every time. So offset 0 collected, offset 1 collected, and offset 2 collected, and then we uh, save that. And then when I increments, we come out to the for loop, and then we go back to offset 1 and iteration. So we go back to our offset 1 iteration, and we say that, okay, now the I is incremented, and so I increments to 2, and then we swap with, because of our swap function, we're going to swap what is at my current offset with what's the new value of I. So B and C are swapped, that becomes CB, so I get, and then I collect what is there at my current offset, so I collect C, so that becomes AC, and then I increment the offset by 1, and I say that whatever is there at the new offset, which will be the last offset, collect that. So A, C, and B will be here, which is what we can see here in the code. So same thing. The point I'm trying to make is I made myself a few mistakes here, but while evaluating this branch, if you have this in front of you, and if you look at your code, you can try to sort of correlate as to what needs to happen in your recursive loop, and then you can, if you made any mistakes, this will help you correct that. So this is your blueprint, and look at this and look at your code and see what it is doing and what it's supposed to do, and that would help you not make too many mistakes. All right. Next, we'll look at combinations, and the two choices were combinations with repetitions and combinations without